So hello friends, welcome back to my channel Medicine Hub 101. Today we'll talk about type 3 hypersensitivity reactions. Okay. So I have already uploaded the video based on the type 1 hypersensitivity, type 2 hypersensitivity. Now we'll talk about type 3 hypersensitivity reactions. Okay. So basically in the introductions part of the hypersensitivity, I've already said you there are the four types of the hypersensitivity reactions: type 1, type 2, type 3 and type 4. So out of the four types of the hypersensitive reactions, the first three, that means the type 1, type 2 and type 3, this type of the hypersensitive reactions, they are what? Antibody mediated. The type 4, that is what? Cell mediated. Okay. I have already mentioned these things before. So in this case, what type of thing we'll get over here? Let's use. See, in these cases we need to know that type 3 hypersensitivity reaction definitely what's the immune mediated what tissue damaging reactions. So it will got the immune mediated tissue damaging reactions. And in these cases the special things over here will get the antigens and antibody both will be free. Okay, the antigens, it may be extrinsic or it may be what? Intrinsic antigens. Antibody against the antigen that will be formed will get within the circulation, that will be in the free form. Okay. So let's write it over here that type 3 hypersensitivity reactions we can consider is the immune mediated tissue damaging condition. Tissue damaging conditions. Okay. And in these cases, whatever thing we'll get over here, see, we'll get the formations of the antigen antibody complex. That means in these cases we'll get what? I'll explain these things with a bit. Antigen antibody complex. This antigen antibody complex that will be formed and deposited on different tissues, the different organs. Okay. Now basically if we just talk about in terms of the antigens, try to understand from here if we say in terms of the antigens, these antigens, it can be what? Extrinsic antigens or exogenous antigen, or it may be the endogenous antigen. Okay. It may be exogenous antigen or it may be the endogenous antigens we can get over here. So when we are talking in terms of the exogenous antigens, definitely different kinds of the microbes we can talk. So we can get over here the exogenous antigens in terms of the bacterial antigens. We can talk in terms of the fungal antigen. We can talk in terms of the viral antigens over here. So see, if we just talk in terms of the bacterial antigens, try to understand from the disease PSG, and that means the post-streptococcal glomerulonephritis, where we will see the antigens where that will be formed against the glomerular basement membrane. So in these cases, the bacterial antigens we can get where in terms of the PSG, that means post-streptococcal glomerulonephritis. If we talk in terms of the fungal antigens, we can get in terms of the farmer lungs. This type of the disease, the development of this type of the disease we can get over there. And if we talk in terms of the viral antigens, let's talk about the hepatitis B antigen. Okay, we'll get over here. And what about the endogenous? Endogenous we can talk. I will explain in the separate video in details about the SLE. So whenever we talk in terms of the SLE, I'll explain once again that the antigens that are responsible for causing the SLE we can get in terms of the endogenous antigens over here. And what about the antibodies? See, the antibodies will get over here. Basically, two types of the antibodies we can get. One is IgG, or we can get IgM. Now, both of the things, like in terms of the antigen and antibody, they will be free in the circulations. Whenever the antigens are free within the circulations, the antibody will be formed against the antigen. Then they will also come within the circulations. After that, they will just combine with each other. Then they will form the complex. And after that they will get deposited in the different kinds of the tissue, the different organs. Okay, sometimes it's also happen that the antigens are formed first, then the antigens are getting deposited on the, for example, if we talk in terms of the PSGM, the post-streptococcal glomerulonephritis, in these cases we will see the antigen that will be formed first, then the antigen that will get deposited within the glomerular basement membrane. After that the antibody that will be formed against it, then again the antibody that will go within the glomerular basement membrane. After going there, that will form the immune complex. So let's write it over here. We'll get the antigen plus antibody. Therefore, they will form the immune complex. And whenever the immune complex will be formed, definitely you will get, there will be activation of certain types of the inflammatory cells. For example, it may be the neutrophil, it may be the macrophages over here. So let's write over here neutrophils. Then after that we will see what the process of the inflammations that will be started over here. The process of inflammation that will be seen over here. Okay. Now we'll talk about in details the what type of the classifications of the types of hypersensitivity we can get. We can get in terms of the serum sickness over here. That is known as what, serum sickness, or we can say that another is what, the arthritis disease. Okay. So we'll talk about first the serum sickness, then we'll go back to the other parts. Okay. Now, based on these things, on the classifications, we can divide the type 3 hypersensitivity into two types. One is generalized reactions, another is localized reactions. Generalized means it can be seen in all over the body parts, and localized means particular organ or particular tissue. You can get it over here. Now, based on these things, we can classify the type 3 hypersensitivity reactions in the two types. One, you can get the generalized, another you can get over here the localized. Okay, so generalized and localized. Now the another name for the generalized, that is known as serum sickness like. Let's write it over here. So we get the generalized reactions, we get the localized reactions. Now the generalized reactions, that is known as serum sickness like reaction. I'll talk about these things, why it is known as serum sickness within a minute. Wait a bit please. And what about it is known as also the arthritis reactions. Known as also arthritis reactions. Now first we'll talk about the serum sickness like reactions. This one. For that thing I need to draw the generalized circulation of the general circulations. Okay. For that thing, I'll just take a piece of general circulations over here. This is the general circulation. Okay. Now try to understand from here that I will draw the two more things to understand this part. And I will draw here the immune headquarters. I will draw the immune headquarters. And I will draw the bone marrow house over here. It's the bone marrow house. Now try to understand from here. If we see for whatever the regions, unfortunately, the immune system, the immune headquarters, they are forming the autoreactive T cells. If they form the autoreactive T cells from here, for example, they are forming the what? Autoreactive T cells. This is the what? Autoreactive T cell. Now, unfortunately, whenever the immune systems, the immune headquarters is the bone marrow house. Bone marrow house. Okay. For whatever the regions, if the immune headquarters they are able to produce the autoreactive T cells, whatever the thing will get over here. Now, what do you know in terms of the bone marrow? What is the functions for the bone marrow? For the hematopoiesis, productions of the what? Blood cells over here. Now, see what do we know within the bone marrow? There is the presence of the stem cell, multipotent or the pluripotent, whatever you can say. There is the presence of the stem cell, and this stem cell will be divided into two parts. One will get from here, for example, another will get over here. Okay, let's. Okay. Now see, one of that I will get what? We will get over here the myeloid stem cells. This is the myeloid, and we will get out the lymphoid stem cell. Let's show the different color for you. Okay, let's use this one. We will get another one, the lymphoid stem cell. It's the lymphoid stem cell. Okay. Now, what is the functions for the myeloid stem cells? By the different processes, they will be able to produce. Try to understand. They will produce what? RBC within the circulations. They will produce also what? The platelets. They will also produce the leukocyte. Leukocyte, except the what? Lymphocyte. Because from the lymphoid, from here we will get what? The lymphocyte. From here we will get the origination of lymphocyte. Okay. Try to understand from here that the myeloid, stem cells, the myeloid precursor cells, they will, the stem cells, they will be able to produce the RBC, platelet, and WBC. Within the WBC or leukocyte, whatever you can say, will get only what? The neutrophil, eosinophil, basophil. Except we can remember over here what? The lymphocytes, because the lymphocyte that will be produced by the lymphoid stem cell over here. Okay. Now, what's the main problem we will get over here? We have to face that these autoreactive T cells, they will go where? After the productions of the autoreactive T cells, they will go where? Within the myeloid stem cells. And what they will do, they will destroy the myeloid stem cells. So whenever we see the destructions of the myeloid stem cells, whenever we get the destructions by the autoreactive T cells, okay, what type of the problem we'll see over here? The main problem we'll face that whenever the myeloid stem cell is getting destroyed, definitely they will be not able to produce the RBC, platelet, and leukocyte except the lymphocytes. So as a result, what type of the problem we'll see here? We'll see the productions of the RBC, that will be less, the production of the platelet, that will be less, productions of the leukocytes, that will be also less. So whenever you're talking in terms of these things, try to understand from here that whenever the RBC is going down, definitely we can consider these things as what? Definitely we can say what? Is the anemia. Whenever the platelet is going down, we can consider this situation as what? Thrombocytopenia. And whenever we are getting the leukocyte, that is also less, we can say leukopenia. Okay. So what type of the manifestations we'll get over here? Try to understand from this figure. We'll get the anemia. We'll get also what? We'll get the thrombocytopenia. Thrombocytopenia. We'll get also, leukopenia. Now these whole things, this whole anemia type of these things, they are known as togetherly what? If I just combine terms for the anemia, thrombocytopenia, and what? Leukopenia, whatever another name for it, if we say collectively them, that is known as what? Pancytopenia. That is known as what? Pancytopenia. So you can write it over here, we will get what? The pancytopenia. Pancytopenia, okay. Now try to understand from here, whenever you are saying that we are getting the pancytopenia, along with that, whenever the autoreactive T cells, they are going within the myeloid stem cells, they are destroying the what? Myeloid cells. So whenever the myeloid cells that will be destroyed, definitely we get the hypocellular myeloid stem cells. So we can say hypocellular activity of the bone marrow. Okay. Along with another term for it, we can say the aplastic or bone marrow, aplastic myeloid cells. Okay. So you can say along with that we will get what? As the T cells are destroying the what? Myeloid stem cells over here. So we'll get the hypocellular bone marrow activity. Okay. Hypocellular. Okay. Activity will be seen within the myeloid stem cells. Now, whenever we get these two terms together, that the pancytopenia along with that or the hypocellular bone marrow in terms of the myeloid stem cells, these two things after combinations, they are collectively known as what? They are responsible for forming the aplastic anemia. They are responsible for forming the aplastic anemia. Remember it. So they will form aplastic anemia. Hope you have heard the name aplastic anemia. So whenever we will get any individual who is having the aplastic anemia, what type of problem we will see that whenever the RBC is going down, definitely the level of the hemoglobin that will be less. So the persons, they will be not able to work that much. Okay. So we'll get what? The effort intolerance will get. Along with that we'll get what? As the leukopenia we are getting over here, definitely the WBCs, especially the neutrophils, if it goes down, whenever the bacterial infections will be over there, definitely the neutrophils will be not able to fight against the bacteria. So in these cases, we will get the effort intolerance. Along with that, we will get what? That okay, the WBC can't fight against the bacteria or the microbes, whatever you can say about it. Okay. Now this type of problem we will see where at the level of these things. So whenever the autoreactive T cells are produced against the myeloid stem cells, we will get the reductions of the RBCs, we will get the reductions of the platelet, we will get the reductions of the leukocytes. Now how can we manage these situations? We should have any kind of the management situations that can manage these situations. Now for that thing, for example, we have taken the antigens of the autoreactive T cells. So for example, if I just say that this is the antigens of the autoreactive T cells, autoreactive T cell antigen, this one. Now if you inject the autoreactive T cells antigen within a horse, for example, before it was used to do, so for example is the horse, it's not looking like horse but you think it's like a horse, okay. Now whenever we put the autoreactive T cell antigen, whenever we injecting the autoreactive T cell antigen within the horse, definitely the horse they will produce what? The horse they will think the body of the horse they will think the immune systems of the horse that will think it's a foreign particles, they will just consider it is the what? Foreign antigen. Against the foreign antigens, the immune systems of the horse, okay, they will produce what? For example, the immune system they will produce the the antibody against the autoreactive T cell antigens. So whenever they will produce the antibodies over here, they will produce the antibodies. Let's so with the red on it's okay. So they will produce the what? Antibodies against the autoreactive T cell antigens. Now if we inject these antibodies where within this human body, what type of the thing will get over here? Try to understand. If we inject these antibodies over here, now the antibodies they will come over here. You get the antibodies. Now these antibodies will also go away against the T cells because these antibodies are produced against the what? Autoreactive T cells. So definitely they will go where within the T cell. Then whenever they will go to the T cells, definitely they will go what? They will destroy the T cells. Whenever they are destroying the T cells, definitely the T cells, the number of the T cells will be less. So as a result, they will be not able to destroy the what? Myeloid precursor cells, so myeloid stem cells. So whenever the myeloid stem cell is getting spared from the what? The autoreactive T cells. After that, we will get that again. Whenever it will just act normally, whenever it will be able to act normally, again we will get the protections of the RBC that will come to the normal. It will be increased. The platelets that will be also increased. The leukocyte that will be also increased. Now the problem is over here. Whenever using the autoreactive, that means we can say over here we are producing what? These antibodies. They are known as what? Autoreactive against the ATJ. That means antibody against the what? Thymocyte globulin. Against the thymocytes. They are producing the what? The T cells over here. Okay. So what can you say over here? Okay, let's write it over here. Anti-thymocyte globulin. They are producing the anti-thymosin globulin. They are produced. After that, they are going within the T cells. That destroying the T cells. After that, we are getting the myeloid precursors. Myeloid stem cells. They are able to function normally. They are they are again producing the normal level of the RBC, normal level of the platelets, normal level of the leukocytes. Now try to understand from this figure. Whenever these anti-thymocyte globulins are coming within the what? Within the circulations, this antibody, that means we can say the anti-thymocyte antibody, this will be regarded as foreign particle by the immune systems of the human being. Okay, in whom we are injecting the antibodies, the immune systems, the immune headquarters, they will regard it as what? The foreign particles. So it will be now regarded as the antigens, foreign antigens. Now by the antigen representing cells, it will be regarded now as what? The antigens with respect to the immune headquarters of the recipient. Now it will be represented by the what? It will be represented by the antigen presenting cells where within the immune headquarters. Now whenever it will be sent over here, then these antibodies, for example, let's over here, this antibody will come over here. Now these antibodies that will be present to where? That will be present to the that will be presented to the T cells. So whenever the T cells, T helper cells, it will be presented to the T helper cells, and whenever it will be presented the T helper cells, that will be activated, and that will activate the what? That will activate the B lymphocyte. That will activate the what? B lymphocyte. And whenever the B lymphocyte will be activated, it will convert it into the plasma cells. And whenever it will be converted into the plasma cells, definitely we will get the productions of the what? Antibody against the ATG. That means anti-thymocyte globulin. We will get the autoantibody against the what? Anti-thymocyte globulin. For example, I am showing the antibody that is producing against the anti-thymocyte globulin with the black color over here. So we will get activations of these things. This plasma cell is activating this one. So we will get the antibodies that will come over here. The antibodies that will come over here. So what they will do, this antibody, they will regard it as antigen. They will consider this antibody as antigens. Now they will do what? They will just form the immune complex with this one against this part. So they will form the antibody against these antigens. Actually, they are antibody, but the immune systems of the recipient, they will consider it as the antigens. In the same way, we will see also over here. We will get also the anti-thymocyte antigen. Now try to understand whenever we are getting this type of thing, the antibody that is produced against the anti-thymocyte antigens. Okay, for example, let me show over here with a large size. Then I think it will be easier for you to understand more clearly. Okay, and it is for example, it is the anti-thymocyte globulin. Whenever it will just come and react with the foreign antigens, the Fc portions of the what? The antibody, that will be activated, and it can attract the different kinds of the inflammatory cells. For example, it can attract the neutrophils. So whenever the neutrophil will come over here, they will secrete the different kinds of the enzymes. They may secrete what? The oxygen-derived free radical. They can also secrete whatever the lysozymes. They can also secrete what? As we know that in these cases we will get the vasogenic products. They will also produce the vasogenic products. Within the vasogenic products, this may be the neutrophil, it may be the macrophage. Okay, vasogenic products. So whenever the vasogenic product, whatever the vasogenic products will get over here, we'll get the histamine. We can get also we can get the prostaglandin, this type of thing. Now whenever the histamine and the prostaglandin, this type of thing will be produced, whatever the changes we'll see further, try to understand from this figure. Okay, for example, I'm just considering this is the endothelial cells. These are the endothelial cells. Under normal circumstances, now try to understand from here, these are the endothelial cells, normal lining. Okay, now whatever the problem, whenever the histamine will come over here, they will cause a shrinkage. They will cause a shrinkage of the endothelial cells. As a result, whatever the figure will get after that, will get not like this one. We will get the figure a little bit different. Okay, before that, okay, let me show over here. We will get the shrinkage of the endothelial cells. We will get the shrinkage of the endothelial cells. As a result, in between the endothelial cells, the intra-endothelial gap, we will get the intra-endothelial gap that will be increased. So intra-endothelial gap that will be increased. So whenever the intra-endothelial cells that will be increased, definitely in these cases, whatever thing will get over here, the permeability that will be increased. Whenever the permeability increase, the more amount of the inflammatory cells that will come over here, more amount of the antigen antibody will come over here, and further we will get the tissue damage. We will get the further tissue damage. We will get what? The further tissue damage. And another problem over here, try to understand from this figure. Okay, again we'll get to what? The more amount of the neutrophils will come, more amount of the the mast cells, different kinds of these things will come. How these things will come? Let's try to understand from another figure. That for example is the try to understand from here. Yes. So the antigen antibody, they will come also over here. So for example is the antigen for is the antigen. Whatever the antigen, definitely actually is the antibody. What we have to regard it as is our antigen, anti-thymocyte antibody. Against what? Against this we will get the productions of the antibody and we know that the Fc portions of this antibody, Fc region that will be activated, and that can activate certain kinds of the complementary proteins. Okay, whatever the complements they will activate, they will produce. They can activate the different kinds of the complements. That's the word C1. First we'll get the complements C1, then we'll get the C4. We'll get again the C2. Again we'll get what the C3b, C3a, that will be removed out. It is having the different kinds of the functions I am going to say right now. We'll get again the what C5b. We'll get the C6. We'll get C7. We'll get C8. We'll get the C9. Now from C5 to C9, from C5 to C9, try to understand. From C5 to C9, this will form the membranated complex, MAC. That will form the membranated complex. Whenever the MAC that will form, they will cause the further damage on the endothelial cells. They will cause the further damage on the endothelial cells. As a result, we will see there will be osmotic imbalance. So there will be further damage on the endothelial cells over here. Okay. Now try to understand. We are getting the C3a, and we also get from the C5b. Another will get the C5a. Now C3 and the C5a, what they will do? Try to understand. So now let's show in these portions. Now the C3a and C5a, C3a plus C5a, they are the chemotactic factor for the mast cell. So the mast cell that will be activated. Whenever the mast cell that will be activated, whatever the thing will get over here. See, mast cell, whenever it will be activated, it will release the histamine. It will release the histamine. It can release also what? The proteolytic enzymes. Okay, proteolytic enzymes. As a result, we will get the further damage. Whenever the more amount of the histamine will be released by the mast cell, definitely they will also release what? The neutrophil chemotactic factor. So more amount of the neutrophils that will come to the site of the inflammatory zones. So whenever they are secreting the histamines, we will get the more shrinkage, so more permeability. We will get the whatever the next thing we are getting the protease. So the destructions of the protein. As a result, progressively we will see this whole thing, the whole story that will go from the endothelial cells to the deeper structures, outer structures. So from the endothelial cells, it will go within the tunica media maybe. Then it will go to the tunica adventitia of the blood vessels layers. I will show you in a couple of minutes this thing, whatever the changes will get. Now one thing I had to say that first, whenever this these antibodies are coming where within this antibody, that means anti-thymocyte antibody, they are coming what anti-thymocyte globulin, we can say anti-thymosins globulin, they are coming within the circulations. At first the mononuclear macrophage they will try to solve the situations, but whenever we will see, for example, the productions of this complex is less, or you can say the productions of the anti-thymosin globulin is less, that is not captured totally, or the size is very small, that is not, the macrophages are not able to engulf this thing properly. Or another thing we can get it over here, that for example these antibodies are coming within the circulation, anti-thymosin antibodies, but the amount of the anti-thymosin antibody is so much that the macrophages, or you can say the mononucleocytic systems, they are not able to handle the situations. Or we can get the intrinsic, we can get the intrinsic deformities, or you can get also here another thing, that is the intrinsic. Okay, let me write it over here. Why the regions are over here? The first things maybe the size is small. So size is small. Whenever we get the size is small, definitely for what? Anti-thymocyte globulin. In this case is the mononuclear, okay, phagocytic system, that will be not able to work. Second thing, more amount of the amount of these things, the anti-thymocyte globulin is more. Definitely these things that cannot be handled by the mononuclear phagocytic system over here. Another thing we can get, whatever thing we can get over here, try to understand that we can get also the intrinsic defect within these macrophages or the mononuclear phagocytic systems. You can get the intrinsic defect. As a result, we can get also, there will not proper eliminations of these things. So ultimately, in a word, we can say that impaired clearance of the immune complexes. So these immune complexes that will be not able to, so we'll get it over here. Okay, so let's continue. I was saying that we can get the size is small, that will be not handled by the mononuclear phagocytic systems, or the amount of the anti-thymosin globulin that is more, that is also not able to handle by the mononuclear phagocytic systems, or you can get the intrinsic defects where within the mononuclear phagocytic systems. As a result, these things will be not handled. So these things they will keep on out progressively. They will go from the inner structures to the outer structures of the blood vessels. Now another type of the thing, what type of the problem we get over here? Try to understand from this figure. Okay, let's show over here. Let's show these things over here. Now what do we know normally? Normally, if you just see the structures of the endothelial cells, see these endothelial cells are in this way. Okay. Now, whenever the platelets, for example, these are the platelets. These are the platelets are going through the circulations, blood vessels. Under normal circumstances, what do we know? They are not able to get stuck. They are not able to get stuck with the endothelial cells because of having the protective mechanisms. They are not able to get stuck with the endothelial cells. So these, whenever they will come over here, they will be repelled back. But whenever the endothelial cells are getting damaged for this region, whatever the thing will get, whenever these are damaged, for example, we will get in the shrinkage of these things. Okay, then we will get whenever it will get shrinkaged, whatever the thing will get further. This endothelial cells, they will lose their property for it was able to inhibit the. Let me show you the different color over here. Whenever we get the endothelial cells shrinkage or we get the damage of the endothelial cells, after that the endothelial cells they will be not able to inhibitions of the stacking of the platelets within them. So after that the platelets they will be able to get stuck somewhere within the endothelial cells. What type of figure we'll get? Try to understand from here. After that, okay, let's over here. So for example, we are getting the endothelial cellular lining in this way. They have lost their properties for inhibitions of the stacking of the platelets. After that, whatever the thing we'll get right now. These things will get the platelets, they will come over here and they will get stuck in this structures. The platelets they will get stuck within these structures. Platelets they will come and they will get stuck. In the same way in the opposite directions also. Okay. Now here we'll get the stacking of the platelets. So we'll get what? The thrombus formations. Stacking of platelet. So we'll get the formation of the thrombus. We'll get thrombus formation. Okay. Another kind of the problem, if we see that the level of the blood vessels layer, what type of thing we'll get from this figure, try to understand. For that thing, let's show in this way. Now try to understand what do you know normally the blood vessels layer is the tunica intima, then we will get tunica media, then we will get the tunica adventitia over here. If you see these structures, okay. Now see here we get what the endothelial cells, we get the endothelial cells layers. No. Now whatever the things we are getting over here. Okay, now see, these are the layers of the endothelial cells in the tunica intima. Now try to understand whatever the things we are getting over here, this whole story, that means the antigen-antibody complex, the different kinds of the inflammatory cells, the neutrophils, the macrophages, the mast cell, the complement systems, all of these things they will be able to invade these things, and after that they will come in these regions. Because of the damaging of the endothelial cells, the whole story, that means the whole inflammatory systems, they will be able to come here within the tunica media. And what do we know? The tunica media, they are having the different kinds of the muscles over here. Now in these cases, what type of thing will get over here? Whenever these things will come over here, for example, within these structures, they have crossed the endothelial cells and they have come within this tunica media. Here we will get what? The antigen-antibody complex. Okay. We will get also, along with that, we will get also what? We will get the inflammatory cell. We will get also the complement system. But this type of thing we will get. After that, whenever they will come, we will get over here the fibrinoid tissue. They will be also able to get deposited in these things. So along with that, we will get also the fibrinoid tissue. Fibrinoid tissue, they will be also able to come in these situations. They will come across these situations, and they will form what? The fibrinoid necrosis. So they will form the fibrinoid or fibrinoid, whatever you can say, fibrinoid necrosis. So they will form the fibrinoid necrosis over here. Now we can say the fibrinoid necrosis is the hallmark of the type 3 hypersensitivity reactions. So we'll get what? The fibrinoid necrosis were within the tunica media over here. because of the deposition of the antigen antibody complex, the inflammatory cells, the complement systems, okay, and the fibrinoid tissues or fibrinoid cells. Ultimately, we will get the formation of the fibrinoid necrosis. This is the hallmark for the type 3 hypersensitivity reactions. Now, the next part we will talk about I said in the two classifications. One is in terms of the generalized or the serum sickness, and what type of the manifestations we will get over after that. Try to understand why you are calling it serum sickness. I'll talk about all these things in the next part of the video. Because see, whenever the immune complexes are going over here, we will get the productions of the different kinds of the interleukins. The interleukin, especially the interleukin 1, the T1 necrosis factor. Whenever it will be, they will be produced, they will go within the hypothalamus, and they are responsible for causing what? Pyrexia. That means they will cause the fever. After that, we will get this, this whole complex that can cause the problem in the joints. They can also cause the what? Arthritis. They can also cause the pericarditis, pleuritis. The different kinds of the manifestations will get over here. Okay. They can also cause the lymphadenopathy. So this type of thing is known as the serum sickness. We can say that the person will feel sick. As in a nutshell, you can say over the whole history is serum sickness. Now this type of thing we'll talk in details in the next part of the video. That will be part 2. Especially it's the type 3 hypersensitivity part 1. Let's write it over here. This is the type 3 hypersensitivity part 1. And the next part I will talk in details after the rest of the parts. Okay? Of the type 3 hypersensitivity. If you think this video is helpful for you, please do like and subscribe my channels, and please support me. I need your support, guys. Now, whatever the things or videos you want, just let me know in the comment sections. And if you don't get any point regarding this whole video, please let me know in the comment sections. I'll read your comment and I'll try to help you guys. See you in the next video soon, and thanks for watching.